Good morning, everyone. I am A. Meghla, Assistant Professor, Department of Mathematics from Nanda Engineering College, Erode. Today, I am going to share my experience from our recent industrial visit to Sparkout Tech Solution, a leading IT company. The visit was insightful and very beneficial for us as students interested in emerging technologies like artificial intelligence and machine learning. About the company, Sparkout Tech Solution is known for its innovative work in AI, ML, and modern IT solutions. During our visit, we were introduced to their major projects and how they implement technology to solve real world max problems. The team was very welcome and eager to share knowledge with us. Next, we can see what is machine learning. So, machine learning is a way for computers to learn from data without being explicitly programmed. This means they can find patterns, improve from experience, and make predictions. And machine learning is now used to everywhere from recognizing faces in photos to solving equations. So the next we can see why use ML in mathematics. So ML helps solve repetitive or complex math problems that would take humans a lot of time. It can also discover a new patterns in data, something extremely useful in research and in education. ML enables personalized learning tools that adapt to the student's level. Machine learning for solving math problems. Machine learning can solve symbolic integrals, equations, and even suggest proofs. A project like Google's Minerva and DeepMind's Alpha Code show how far we have come. These tools process natural language and mathematical notations to give step by step solutions. One real world example with discrete mathematics. Let's take traffic signal timing optimization as a real world example. A city wants to minimize waiting time at intersections. Machine learning can analyze traffic data and predict the best timing. Discrete math helps model roads with graphs and use probability to predict flow. Next, we want to discuss about what is NLP. So, NLP means Natural Language Processing, or NLP allows computers to understand and respond to human language. In mathematically, it powers tool like chatbots that help students and search engines that understand math questions beyond the keywords. And then we want to discuss real world problem for NLP. Here, so how NLP solves a real math world problem. It breaks down the sentence, finds the quantities 60 kilometers and 1.4 hour, and figures out that the quotient is asking for speed. Then it applies for the formula and gives the answer 40 km per hour. So see the figure. like where it is used AI. These are popular tools that use AI for math help. So Microsoft Math Solver and Wolfram Alpha and even ChatGPT. They use both NLP and ML to interpret and solve problems quickly and correctly. And then we can see tools used in NLP for mathematics. So several tools help implement NLP in mathematics. Spacey and NLTK process language. Simbi converts words to equations. Transformer like P or T help understand complex questions. And LaTeX NL converter turn natural language into math notation. So next, what is deep learning? So deep learning is a part of machine learning that uses large neural networks to learn from big data. It's called deep because of the many layers involved. It powers image recognition, self-driving cars, chatbots, and more. And one simple example, here's a simple DL example, a deep learning example. The model sees a cat image, converts pixel into numbers, and uses math like linear algebra and calculus. This is to understand it. Okay, so it uses derivatives to improve and learn better next time. So on the next tools what we can use, these are some of the tools you can try. Python libraries like TensorFlow and PyTorch are used for building models. And NumPy, SymPy and Matplotlib help with math calculation and visualization. So see the picture. So the next key steps in deep learning. Deep learning involves 4 key steps. So the first one, forward propagation, that means calculate predictions. So the second one, loss function, that means measure errors. The third one, backward propagation, that means update weights using calculus. And then repeat, that means improve with every cycle. And then next slide, applications by area. So AI and ML apply to many math fields. In statistics, we do predictive modeling. In optimization, we solve real life scheduling problems. And then linear algebra powers neural networks. Okay, game theory, it is used in AI decision making. And then real life examples,